Hello and welcome to a very special video brought to you from space. This is part of Oxford Sparks Science at Home campaign. That's hashtag Science at Home, which involves every Tuesday and Thursday bringing you things like Twitter takeovers, live Q&As and videos like this one. So subscribe to the YouTube channel to make sure that you can watch all of the great videos, and follow Oxford Sparks as well on Twitter, YouTube, Facebook and even Instagram. So the video that we are bringing to you is all about space, and I'm very excited to be here because I love space. If you don't know who I am, my name is Jordan Erica Webber. I am a presenter. You may have seen me on the Gadget Show on Channel 5, where I talk about video games, but I also love other nerdy things like other technology and sciencey things like space. So what we're doing today is we're bringing you a debate of where in the solar system would be the best place to spend lockdown other than Earth. So we're all isolating right now, and the best way to isolate is to go. So what other planet, or maybe moon, would you hang out for the entirety of this lockdown? And to decide that matter, we've got two experts, and I will let them introduce themselves now. I'll start with Helena, I think.
Oh, okay, me. Okay, hi, my name is Helena. I am a PhD student at Oxford University, but also at the Natural History Museum in London. And I study meteorites and asteroids, and I'm looking at the origins of the solar system.
Hi, I'm Neil. I'm at the University of Oxford in the Department of Physics, and I'm a planetary scientist, and I study planets all over the place, looking at how they formed and how they evolved, and also we help build things that go there as well. So we build space instruments too.
So obviously these two are perfect place to answer this question of where we should spend the lockdown if not here on Earth. Now, basically what's going to happen is we've got 8 locations. I've written them down on pieces of paper and I've put them in a hat. I actually had to dust this hat off before I used it for this because I obviously haven't been outside in a while. So I had to get a little mini vacuum out to get the dust off that. But for each round, what I'm going to do, we've got 4 rounds, and I'm going to draw a name from this hat for each of our experts. And they offer their arguments for why that would be the best place to spend lockdown. Then they will have the chance to argue with each other if they want to. And then I've got some questions lined up just in case as well. I'm going to say about 5 minutes per argument, experts, if that's okay. I know you know a lot about the solar system, but if you could keep it to 5 minutes, that would be grand.
We'll try.
Good, glad to hear it. And then you, people at home who are watching, you are going to be able to vote. So you can help decide where would be the best place in the solar system to spend lockdown. We are going to have votes here on YouTube and on Twitter as well. So follow us at Oxford Sparks on Twitter. You can also follow Oxford Sparks on Facebook and Instagram as well. So make sure you do. So I'm not going to spoil what the locations are ahead of time. We'll just let them come up for each round. So, experts, are you ready?
No, I'm nervous.
Well, luckily, Helena, you're going first.
Oh, great.
So we've already had a chat before this about which locations Helena is dreading getting. So let's see. Okay, I've pulled a name.
Oh, no.
It is...
Okay.
Oh, first.
Saturn for Helena, and then
Not
Neil.
the worst of the gas giants, so it's all right.
Neil won Saturn with Neptune.
Yes! Oh, I didn't get Neptune. It's all good.
Okay, excellent. So, Helena, we are going to give you 5 minutes.
5 minutes.
Countdown, but we'll roughly estimate how long you've gone for. So 5 minutes on Saturn, the dressiest planet in the solar system.
Planet. All right, so shall I start then? Well, let me just change my background. Hold on.
Okay. So yes, you've got to fly to report from Saturn.
There we go. Saturn. Yay!
Having it live.
Okay, so Saturn is the second largest planet in the solar system. It's quite far away. It's I actually don't know the exact AU away, but it's further out than Jupiter, further out than Earth, and obviously all of that. And it's a gas giant, which means that the majority of its outer layers are gas, and there's not really a kind of solid layer, if we were to go there, that we could really stand on. So if we were going to live directly on Saturn, I think we would be quite limited in terms of our capabilities. We'd probably have to have some sort of flying blimp-like thing that we could sit in, which could be quite interesting. And there is some evidence that some of the areas like in the outer layers have Earth-like pressures, which means that you wouldn't have to wear a pressurized spacesuit and all that kind of thing, which is quite good. It also, the atmosphere has got lots of hydrogen and helium and all this kind of thing that we can use for fuel. So it's good. You know, that's decent.
And we've got a helium shortage on Earth, right? So
exactly. So we can ship stuff back. But actually, probably if we were thinking about Saturn, the best places to live wouldn't actually be on Saturn itself. It would be to live on some of the moons. And there are basically 2 moons that I've identified that, well, actually, I'm going to put 3 because one of these moons is really, really awesome that I think we could potentially live on. And those are Enceladus, Titan, and then I really like, I think it's pronounced Mimas. And the reason I really like Mimas is because it looks like a Death Star. But apart from that, there's not really any other reason for why we should live on it. So Enceladus is one of the moons of Titan. It's got a solid surface, which is a plus. It's potentially got some sources of heat. It might also have a kind of liquid ocean water layer on the underneath, and obviously water is very important if we're humans and we're going to be living there. We need things to drink. We can naturally extract oxygen from the water, and
we can go surfing.
Yeah, exactly. Yeah, it'd be. Well, maybe, I don't know if we could go surfing on it. I mean, not so ideal. So it's not a bad place, but I think that the best place to live, and I'm going to change my background to be Titan. Oh, that's Triton. Wait, hold on. Where's Titan?
Picked my moon.
I'm sorry. It's your only option.
Moon theft going on over here.
Here's Titan. Titan! Yay!
Wow, look at that.
I know, very interesting, very, lots of surface features and all this kind of thing. So Titan is actually, it is one of the only moons in the solar system which has ever, it's actually one of the only other places in the solar system which has got evidence of lakes and oceans and things on the surface. And the reason it has that is because it's actually got quite a thick atmosphere that acts to kind of like, that has quite a lot of pressure on it. The problem is that the lakes and oceans on Titan are actually made of hydrocarbons rather than water, which is obviously not great, but hydrocarbons are a source of fuel. That's really good. The thick atmosphere actually will act to protect the surface from some radiation. It also, the atmosphere, it means that you don't have to have pressurized spacesuits and all that kind of thing. And the gravity is kind of like low, and the thick. So this is one of the things I found out. If it's low gravity and thick atmosphere, it means you can actually fly, which will be really fun. And Titan is actually going to go and be investigated by a mission called Dragonfly, where they're going to put a drone essentially on the surface of Titan, and then we're going to find out a lot more about it in the upcoming decades, which means that we might even find it's even better for human colonization. So yeah, I think Titan would be great, though. The lakes are very flammable, so if you smoke, I don't think that's very good. It might not be for you, so yeah.
Well, you probably shouldn't be smoking right now anyway.
No, probably not.
Not in the current. All right, is that your argument, Helena?
Yeah.
Excellent, perfect. I'm going to summarize your argument as water sports.
Okay. Yeah, okay, I'll take that.
We've got lakes, we've got under the surface, oceans. Sounds incredible. I forgot to mention at the top that moons are allowed. So for each planet in the solar system that has moons, if you get that planet out of the hat, you also get all of its moons. And that's great because Saturn at the end of 2019 overtook Jupiter as the planet with the most moons. Am I right, Neil?
Oh, probably. So something to stop counting.
But they're both got in the 60s, haven't they? They've got about 60 moons each, something like that.
You got loads.
Too many.
Loads.
Loads of moons.
An embarrassment of moons.
Yeah, some of them are bigger than others. A lot of them are quite small though.
Well,
Well, Titan is one of the biggest moons in the solar system. So.
All right, Neil. Neptune, are you ready?
Oh, I'm ready.
Good luck.
Right, so many would have thought that Helena had hit the jackpot early with getting Saturn, the most beautiful ringed object that we all think about when, you ask to draw another planet, and someone draws a planet and they draw rings around it. Well, as you can see behind me, we have Neptune. Now, Neptune is a really crazy place because it's another gas giant. It's not as big as Jupiter or Saturn. It's a bit smaller. It's about the same size as another planet called Uranus. Excuse me. It's mainly made of hydrogen and helium as well. but has a lot more. But because it's much further from the sun, it's about 30 times distant from the sun than the Earth is or so, then basically it's a lot cooler, a lot colder. So you might think that because it was cool and cold, it'd be kind of boring. But it really isn't. And for reasons we do not understand. So this would be, as a scientist, of course, I would say this, wouldn't I? But I want to go there because we really want to understand what's going on in the inside of this planet, and we want to understand how the atmosphere is churning. Because, again, if I move away, this is an image taken by the Voyager 2 spacecraft. It's the only spacecraft we've ever had that has flown past Neptune. It flew on its way out of the solar system all the way back in 1989 or so, I think. So it's a really long time since we've been there. But we expected it to be kind of dull, but it wasn't. It had this incredibly dynamic atmosphere, which was winds whipping round at hundreds of kilometers per hour, and really interesting cloud formations and stuff like that. So it's a very interesting and really strange place to go. One of the other things it does have rings. They're not particularly bright. Most planets actually in the outer solar system have rings. They're not as spectacular and as amazing to look at as...
Yeah, you can't use the ring argument. I mean, Saturn.
Yeah, we got rings. You got rings, we got rings, right?
So Neptune is, if you like your jewellery a little subtler.
Yes, it is. It's more restrained.
Mm-hmm.
However, since moons are allowed, I thought I'd kick in one here.
Ooh, we don't know a lot about the moons of Neptune.
So here is one of the biggest moons in the solar system, a moon called Triton. Now, Triton, you wanted water sports, I could give you crazy skiing, right? So Triton is one of the largest moons in the solar system, a bit like Titan, which is a moon of confusingly similarly named for Saturn. But the thing about Triton is it's very white. He says moving away again, right? And that means it's it wouldn't be a particularly great place for people outside of a spacesuit, like most of these places, because it'd be one of the coldest places you could visit in the solar system. The temperatures are down at minus 230 odd degrees centigrade because the surface is probably covered in nitrogen frost. But what's really quite interesting about this is, so you could go skiing on the nitrogen frost, assuming you didn't scoop it out because you're too warm and sink into it, but that's another issue. But one of the things you could do on Triton is there are these spectacular erupting geysers of nitrogen gas that were seen by the Voyager spacecraft as it flew past. So you'd see these big erupting features that then dump into a very, very thin atmosphere and sort of shoot almost vertically upwards and then go along. You can see those going along. So it'd be a really exciting place to visit. And of course, you'd have these fantastic views of Neptune. And Triton's another really weird place to visit because it actually orbits in a different direction, the other way around the planet than all the other moons in Neptune's system. So it's probably actually an object that was captured by Neptune from very early in the solar system. So it's a very ancient and weird place. But it looks like it's got a very dynamic surface because it doesn't have that many craters on it. So it looks like a kind of crazy, weird place. It would certainly be an interesting place to go. So yeah, Saturn looks good. As we said in the 90s, it's got the bling.
Don't worry, Neil, you convinced me. I want to go to Triton now.
Let the viewer decide.
Yeah.
I have a question about Triton, Neil. If it's going the other way, does that mean it's at risk of crashing into something else?
No, it's in a stable orbit, but it probably didn't start out life forming with Neptune. So yeah. So
if there was going to be a moon that had aliens on it, Triton from elsewhere. No,
definitely not.
I think we agree on that.
We don't use the A word. If you were looking for aliens, right? Then
we said we didn't use the A word.
If we were looking for aliens, microbial, simple life forms, well, Helena, would you like to explain where you might find out?
Neil is saying this because I'm completely obsessed with aliens. This is. I mean, I actually think that Titan might be better if you were going to look for some form of extraterrestrial life, because actually hydrocarbons are organic molecules. And organic molecules, as we all know, not life, but the building blocks of life. And obviously, if Titan has a lot of hydrocarbons on it, and, it's got a pressurized atmosphere, it's got decent gravity, not great, but it's not the worst. That is a kind of recipe for potentially life emerging. We don't know. So
Excellent.
maybe I would put money on Titan over Triton.
Actually, the other place in the solar system that has got really strong life cred is Enceladus.
Oh yeah. Okay.
Yeah, I mean everybody loves Enceladus, right? The huge erupting geysers at the south pole of the Saturn's moon, Enceladus. Here I am selling Saturn when I shouldn't be. But then I did work on the Cassini for a very long number of years, so I'm kind of biased. So Enceladus has these large erupting, essentially plumes of water ice, and we think we detect complex molecules in the plumes there as well.
We have a picture of the thingy.
Of Enceladus.
Of the,
Yeah,
I've got a poster for Enceladus on my wall, revealing my personal bias here.
oh yeah, sorry I didn't spend more time on Enceladus then.
Oh, that's all right.
Oh, no.
Well, the viewer gets to decide. What seemed in this round is that the two of you have convinced each other of the merits of your own.
I mean, I don't think Triton is really. It's a bit cold.
Really? Oh.
Well, you know, some people, they run really hot. You know, the kinds of people who they always kick off the covers at night when they're sleeping. Maybe they would want to go somewhere where it was a little bit cooler right now. Do you two have any more ways that you want to challenge each other before we move on to the next round?
I could go big on,
no,
and it being, very low. The density is very low. You can't breathe the air.
Yeah, but neither can you on Neptune. I mean, it's like it's not.
I mean,
I remember there was a fact that that I used to know. Or I used to always bring out was that if you put Saturn in an ocean that was big enough to hold Saturn, it would float.
Wow. See, I think Saturn's moons especially have a lot going for them. You know, the water sports, as I mentioned earlier. I think maybe the downside of Saturn is that it is possibly everyone's favorite planet already, so it's maybe a bit overrated as a holiday destination. Whereas Neptune, sure, it's cold, but no one's really been there. So it's one of those.
The other thing that Neptune's got going for it is it's the kind of closest body to the outer solar system to things like the Kuiper Belt, which is this kind of collection of icy, rocky bodies outside the orbit of Neptune, where Pluto is located. And for me personally, I'm very interested in the Kuiper Belt because it's a very bizarre leftover kind of primitive body graveyard. So I'd like the idea of going to Triton because you could use it as a sort of base for investigating even further out.
I love that idea of it being a graveyard. One for the goths.
Exactly.
Okay, round 2. Are we ready?
Right.
Yeah.
I'm shaking the hat.
Right.
I'll pick Helena first again. Praying for not another gas giant.
Oh God.
Okay, what have we got here?
Oh no. Okay.
Venus.
Okay. All right.
And then,
who
do you
do I
want
get?
to change your background, Helena, while I'm
Oh yeah, I'll do that.
picking Neil's name from the hat? I'm trying to show it so that people don't think I'm doing this. There we go. We got Uranus.
Okay, I get the gas giant again.
Neil gradually flying in from the outskirts of the solar system. Okay.
Yeah, a Uranus one up.
Oh, Helena, that's beautiful. So we've got Venus, otherwise called the morning or evening star.
Yeah, it's been very visible recently, hasn't it? Should we let Neil go first this time?
Sure.
Thank
Neil,
God.
to go first.
I've got to get my background sorted.
Uranus, I've got written down here as the wild child sideways planet.
Yeah, it rolls around the sun like a kind of rolling pin.
Things different.
Uranus, yes, it's the apple planet where you think different. God, that marking worked well, didn't it?
That's great. You're going to have to, your head is based. Oh, there we go. That's lovely.
It looks like I've got a halo.
Oh.
Okay,
Right.
Neil, are you ready?
Okay, so Uranus. So Uranus, apart from it having a hugely humorous name, that Uranus is a kind of weird place. It's definitely the place for the, how would I call it? The outsider, the person who likes to tread a different path, because it's about the same size as Neptune, so it's smaller than Jupiter and Saturn. So it's not like one of the big ostentatious planets that we've got. It's kind of somewhere in the middle. It does have a really nice system of rings, which you can see behind me.
Oh, lovely.
And so it does have a system of rings, which is kind of interesting. And they were discovered actually fairly recently, in the late 1970s, by an airborne telescope on an aircraft. Well, way back in the day. But the thing about Uranus that's really, really crazy is that it actually doesn't actually spin on its axis in the same way as all the other planets. It's tipped over on its side. So that it's spinning this way round. If the sun was over here, he said, putting his hand in so it can be seen, it spins like that. Most planets spin like this. So what that means is it has absolutely crazy seasons. Basically, the planet will rotate between North and South Pole facing onto the sun. And so if you can imagine what that would be like on the Earth, you'd be having extreme winters, extreme summers, absolutely crazy. It also has a very complicated system of moons, which also orbit in the same plane as Uranus rotates. So again, very different to the rest of the solar system. So something absolutely crazy happened, we think, early in Uranus's history. So when it was forming. Now, it's another planet that we've only visited with a spacecraft once. That was Voyager 2, again in about mid-1980s, I think 1986 or so. And when Voyager 2 went there, it just looked really boring. I mean, it just looked like a kind of greeny, bluey blob. Again, it's made mainly of hydrogen and helium with bits of hot, watery, icy stuff interior, and then trace amounts of nitrogen and methane and other things like that. So it's not what you would call a breathable atmosphere by any means. It's also much further from the sun and the earth, so it's also very cold. But when we went there, it was just this kind of very dull green blob. And everybody went, huh. Okay. Because we've been kind of spoiled by Jupiter and Saturn. And it turns out, though, that just because we happened to be seeing Uranus at that point when the weather wasn't that extreme. And as we've watched it with telescopes now from the Earth, we've seen much more vigorous weather kicking off in the atmosphere of Uranus, which is really kind of dynamic and interesting to look at. So there's a lot of really crazy stuff going on with Uranus that we just don't understand. So again, as a scientist, I'd really like to go there, send a space mission there, because there's an awful lot we can learn about how planets have formed and how they've been combusted up and turned around. But since moons are allowed, I think I would also point out that another reason that you might want to go to Uranus is it's got some really interesting moons. Now, let me just...
what I'm getting from Uranus is that you'd have to pick the right season to go there.
It's a very seasonal place, so a bit like Blackpool.
Uranus, the Blackpool of the solar system.
Yeah. Let me just see if I can... Oh, here we are. Right. So this is a moon of Uranus called Miranda. And this might be giving us some clues as to why Uranus is such a different kind of place, why it's ploughing its own path, as it were. Now, if you look at this, you can see it's got some absolutely crazy sort of structure. It looks like somebody took a moon. And remember, when you're so far out in the solar system, rock and water ice are pretty interchangeable because it's so cold, the ice is as hard as rock. Mm-hmm. Took a kind of rocky, icy moon, got a massive hammer to it, smacked it up, and then reassembled it. If you look at this, you can see these massive blocks of things. So there are huge cliffs on Miranda, so it'd be an amazing place to go abseiling, especially in low gravity. So you'd be able to and then sort of float down. No atmosphere, so you'd have to be in a spacesuit, obviously, it's terribly cold. But
you know, a lot of my friends have been missing climbing. Like, I've got a lot of friends who are really, really into climbing, and they can't do it right now. So it seems like Miranda would be a great place to go for that.
Yeah, I think for the free climbers, it's probably a win. Mm-hmm. Because even if you fall off, you're still probably going to be all right in the very long. But the really weird thing about this is it probably tells us something about how the moon itself. It might, the fact that it looks all smashed up. This might be a clue to something that happened early on in Uranus's history. Maybe as the planet was relatively young, there was a massive violent impact to the Uranus system, tipped the planet over, and then disrupted all the moons that were forming at the same time. We don't know because we need to go back and have another look. I would say that would know, but but basically it's an absolutely crazy place. So Uranus You've got to pick your right season, but if you pick your right season, you're in for a ride. And Miranda is definitely a place to see what happens when you smash the planets up and put them together again.
Excellent. Helena, over to you.
Well, okay, so we're actually going from the coldest place in the solar system, because Uranus is a little bit weird in that it's considered the coldest place in the solar system. It's even colder than Neptune, to actually the hottest place in the solar system. So I think it's quite good that these two have been paired together. So I am left with just Venus. Venus doesn't actually have any moons, so I'm going to argue the case for Venus on its own. But you know what? I think it's got a lot going for it. So
is Venus the only planet in the solar system that doesn't have moons?
Mercury doesn't either.
Ah, okay.
Yeah.
Good to know.
So Venus is the second rock from the sun. It's one in closer to the sun than Earth is, and it's actually termed quite often a sister planet for a number of reasons. The main one being that it's actually a very similar size in comparison to the other terrestrial planets. So Mars is quite a bit smaller than the Earth, but Venus is very similar, and that means that it's actually got a very similar gravity on it. It's about 0.9 or 90% of Earth's gravity, which is really good if we're going to be living there, because you don't have all of these issues with like microgravity and loss of bone density. You could just live very happily, but you would be a little bit lighter, just a little bit lighter. So that's fine as well. The problem with Venus is that it's an unusual place because it's got an incredibly thick atmosphere. And some people have used it as an argument to say this is a runaway greenhouse effect, because the atmosphere is mostly made up of carbon dioxide and it's basically trapped all of the heat on the interior of the planet, which means the surface of Venus is really, really hot. I think it gets up to something like 430 degrees Celsius on the surface. And because of that really thick atmosphere, the pressure on the surface is also really, really high. And I looked it up, and apparently you could cook a pizza on the surface of Venus in 7 seconds, which I think is pretty amazing. Exactly. So, takeaway would be really, really fast.
Uh-huh.
But actually, one of the places in Venus that could be relatively happy and we could live in is about 50 kilometers up into the cloud layer, where the air pressure and the temperature is actually far more tolerable. It's about 50 degrees centigrade, and the air pressure is very similar to Earth's. Not bad, really. When you're thinking about the other places in the solar system, we've got a place that's similar in temperature and similar in pressure to Earth. I think is a pretty safe bet. The problem, though, with that is all of the clouds are made up of sulfuric acid. So we'd have to find some way of dealing with the acid corrosion-y type issues.
Presumably it would also be quite smelly.
Probably, yeah. We probably have to wear some sort of... We get used to it, probably. But the other thing is actually it's close to Earth, which means that we'd be able to contact our friends back on Earth in a much shorter period of time than it would say if we were out at Uranus, which I think is a plus, because I don't think very many people would really want to go and live on Venus. But it could be good. What else can I say?
Do you know what the distance is from Earth to Venus? Do you know how long it would take to do, like, if you sent a recorded message, how long would it take to arrive?
I don't know exactly. I reckon it's probably similar to maybe like 20 minutes, probably something like that. In that kind of ballpark, right? Neil, do you know?
I don't, but it's probably about 9 minutes or so.
Oh, less than that. Okay. Oh, yeah. Okay.
Right.
Yeah, depending also on whereabouts Venus is in its orbit and how close we are to it exactly. But yeah, I mean, it's not a bad place. You could get some pretty awesome, cloud surfing. Things. You could cook your pizza really, really fast.
I think that's the best argument that I've heard, I think.
So you're being simultaneously boiled, crushed, baked, and probably acidically corroded. Doesn't factor into it.
I mean, but you get your pizza.
Yeah.
You're not freezing to death, are you? And you're not like suffocating to death. And you're not...
Delivery is still a thing here, right?
Okay, right. Deliveroo delivers to Miranda, right?
There are delivery options.
Deliveroo takes much longer than 7 seconds.
Yeah, but the problem is that if you leave it exposed for 8 seconds, it's basically just a block of carbon.
Well, you got to eat
That's
it quickly.
True. It would burn very fast. The other problem with Venus is there's actually no water, no evidence of water on it at all. All of the water is, I guess, evaporated away because it's so hot, which means we would have to come up with a different, a way of producing something we could consume.
I have some Venus and Uranus before we move on. The question is, lots of carbon dioxide in the atmosphere, so presumably it would be great for plants. If you wanted to bring in plants with you, they'd be really happy.
Yeah, I mean, I guess so. They probably, and actually they would produce oxygen. So, you know, maybe this is a way of terraforming the surface of Venus.
There you go.
Yeah.
And Neil, question about Uranus. Am I right in thinking that Uranus and Neptune switch places in the orbits as how far away they are from the sun?
Well, probably. There are computer simulations which show that Uranus and Neptune could well have swapped positions in the early solar system as the solar system was forming. And in fact, this is where things like the Kuiper belt come in again, because it would have been interactions between all the little bits of leftover stuff out in the outer solar system, gently tugging at the big planets as they were forming, that caused them all to swap positions potentially. So the early solar system would have been a crazy dynamic place with all sorts of stuff going on. So, for example, Jupiter and Jupiter could have moved much closer to the sun before then coming back out again. That's certainly something you can simulate using numerical models, computer models of the solar system. And
it also explains why you see a lot of exoplanets that are Jupiter-sized close to the sun. So.
Quite possibly, yeah. And then also got the fact, so the swapping of positions of Uranus and Neptune would have been a direct result of all these interactions going on in the early solar system. Kind of fun and complicated, and also important for why we have terrestrial planets.
Yeah. But it's Neptune and Pluto that swap the orbits.
Ah, okay.
No,
Pluto we're not talking about.
No, Neptune and Uranus. Pluto's
Neptune and Uranus. Okay.
Yeah, and Uranus could have swapped positions.
But like as in their orbits, like one crosses.
Pluto. This is one of the reasons why Pluto is so totally nuts, right?
We're going into the Pluto.
Pluto is not in this hat.
No, Pluto's not a planet, right? Okay.
Oh, we're going to get hate comments.
It does go occasionally. It does get closer in its orbit than Neptune does.
Yeah.
Right.
Yeah,
so it's tilted to the plane of the rest of the planets. Its orbital plane is tilted. So it's not even orbiting in the same plane.
It's doing its own thing. You know, it's a rebel.
Its own thing out in the corner.
But actually, being a dwarf planet isn't a bad thing. I know people get very upset about, poor old Pluto. But actually, when Pluto got demoted, other things got promoted as well. This is what's exciting, is that other bodies in the solar system got promoted to dwarf planet status, including my favorite thing in the solar system, and on that one that I wish was on the list, Ceres, which is the largest asteroid in the asteroid belt, got promoted to dwarf planet from asteroids. So
Helena, I think what we're going to do is when we do the Q&A video, which is a different video from this, we will talk about Ceres and we'll talk about all of your favorite things that are not in this hat. But for now, unless you have any more challenges for each other, Venus and Uranus. Yes, the hat speaks. We're going to move on to the next round unless you have anything to say to each other.
No, I think I think we all know Venus wins, but Neil is better at making an argument than me. So.
All right, well, let's see how Neil does with the next one. Although I'll stick with the formula and go with Helena first. What have we got? What do you think it is? Neil's going to be so unhappy.
I know. This is the thing that Neil has discovered recently, is that I don't like. I prefer the moon to Mars. So.
Wow, that's saying something.
So what the viewer may not know is that Neil has been working with Mars recently, but sadly that is Helena's planet for today. So Neil will have to keep his love for Mars to himself for the sake of the debate, and instead form an attachment to Mercury.
I was so worried he was going to get the moon, because to be honest, I would not be able to take on Neil on the moon. So
Mercury. Hang on.
All right, congratulations, Neil. You've got Mercury. Helena, you've got Mars, and it is your turn to go first.
Okay, so Mars. Mars is probably the most studied planet in the solar system, apart from Earth and maybe even the moon. But I would take a guess that actually Mars is probably the one that's being most investigated at the moment. It's got the most number of spacecraft in orbit around it. I don't know the exact number. It's also got the most number of rovers and things on its surface at the moment, including one that Neil is involved with, called InSight, which is an instrument on the surface of Mars, which is looking for Marsquakes and using those Marsquakes to try and determine what the interior structure of Mars is. So whether it's got a core and a mantle and that kind of thing, whether it's similar to Earth. So Mars is the fourth planet in our solar system. It's one out from Earth, and it's the kind of end of the terrestrial planet zone. But it is still a rocky body, so it does have a solid surface we can stand on. And I think solid surfaces are very important when we're thinking about the rest of the solar system. So standing on it is a plus. It's also got an atmosphere. It's a very thin atmosphere, but it is an atmosphere which protects you somewhat from radiation from the sun and all that kind of thing. So it's not bad. It has some pretty extraordinary geology. We've got a giant canyon. I don't know if you can see is that the giant canyon?
Yeah.
Giant canyon. Oh, I can hear a lot of like whooshing.
That might be my, let me mute my microphone.
Oh, it might just be my anyway.
That's probably my fan spun up.
So it's got some incredible geology. We've got this is the Valles Marineris, which is basically a giant canyon, but it's even bigger than the Grand Canyon. So it provides some absolutely extraordinary views for sightseeing. It's also got the largest volcanoes in the solar system, including Mons Olympus, which is the largest volcano in the solar system. I actually don't think Mons Olympus is going to be that interesting to look at because it's so big that when you're standing on it, you can't really see it, which is, look at Neil's face. No.
You could hike it.
And hiking would be easier, right? Because the gravity is lower.
Exactly. But the thing about Mons Olympus is that it is like the slope is so gradual because it is so big that actually I'm not sure you would spot it. But anyway, so Mars is really, really interesting. It's got this interesting kind of dichotomy between the northern hemisphere and the southern hemisphere. Northern hemisphere is actually really quite smooth, and it doesn't look as though it's got very many craters and things like that. And the southern area is very high. We call it the Southern Highlands and things like that. And that kind of has led people to believe that there was at one point a liquid ocean in the northern hemisphere, or set of lakes or something, we don't really know, which actually suggests that Mars might have been, quite similar to Earth in its early history, which is really, really interesting when we're thinking about emergence of life and things like that. We have seen evidence from some of the missions that have been there that there are rocks that form in the presence of water, which is cool. Water's great. But if you were going to go and live there now, there are in the subsurface layers, it looks as though it's got some groundwater in it. But then also you can see up here, the poles have actually got frozen water in them. So that might be a really good source of water if you're going to go and live there. What else can I say about Mars? Ice skating. Yeah.
I love ice skating.
It's the temperature is cold. Okay, it's about minus 63 degrees on average, which is warmer than all of the other gas giant moons and things like that. But it can get up to temperatures of about 30 degrees, which I think is probably the most balmy place in the solar system other than the Earth. The most sort of like happy medium place that we could live on from the other. I actually think I have an argument that the Mars is more interesting than the moon because Mars is its own unique geology and the moon is just a chunk of the Earth. But we haven't spoken about the moon. But I thought I would throw that in there.
I was going to say, the moon is still in this hat. We haven't even got to the moon yet.
I know, but I just needed to say that. So I think the other thing is the days on Mars are very similar to Earth. I think it's about 28-hour days. So, you wouldn't have to really mess up with your... No?
24
yeah,
hours.
no, that's...
24. Is it 24?
Yeah.
Basically the same. Even better. Thanks for supporting my argument. Oh, well, see,
it's would be just fine.
Yeah, exactly. So, I actually think Mars would be a bit... I mean, we would have to kind of like... Oh, sorry, my cats are fighting. No.
No
Okay,
cats
fine.
on Mars.
No cats on Mars. You would have to have some sort of... you wouldn't be able to breathe the atmosphere, so you would have to be wearing a spacesuit and you would have to have some sort of like shelter to protect you. But actually, the winds aren't like, we've all seen The Martian and the thing falling over, but in reality, the atmosphere on Mars isn't really strong enough to support winds and storms of that kind of ilk. So, it's pretty good place, I reckon.
Excellent. Neil, how's Mercury looking?
Yeah. First, I'm going to hold that Mars video for later use. Right, Mercury. Okay, so this is Mercury. taken by the Messenger spacecraft, which was a NASA mission to Mercury in the late 2000s, early 2010s, which provided us with some first really detailed maps of the surface of the planet. Now, Mercury is the closest planet to the Sun, and it nips around in its orbit in about 88 days. So it's really a quick thing going around the Sun. Now, you might think that because it's so close to the Sun, it would be the hottest place in the solar system. But it's not quite as simple as that.
I love what you said about Mercury being so quick around the sun that its years are 88 days long, because that means that on Mercury, 2020 will be over soon.
Yeah, 2020.
It would already be over pretty much, wouldn't it? So.
It's pretty much over. I mean, it's got a lot of other weird things, like its day is very long compared to its year. So that's really odd. And there are places on Mercury where on the same day you can see the sunrise and sunset twice. Just for the rotation, because of the way it sits. It's very odd. But other thing you might notice, if I get my head out of the way, right, is that it looks kind of like the moon. But it really isn't like the moon. That's one of the most important things. It's made of very different stuff. And the really, really crazy, weird thing about Mercury is that, most of us have seen pictures of what we think the insides of planets look like. Yeah, they kind of look like an onion where you've got kind of a middle bit and then lots of layers going out. So on the Earth, you've got a core, then you've got the mantle, which is the sort of hot, rocky bit, and then you've got the crust that we all live on. And there's quite a lot of mantle. On Mercury, the core takes up the vast majority of the inside of the planet, made of iron. So this thing is basically a big ball of iron with a thin layer of rock around the outside, for want of a better expression. And we don't know why that is. There are lots of interesting reasons as to why. Again, we're going back to Mercury with a European Space Agency mission called Bepi Colombo in about 5 years' time. It just flew past the Earth on its way out there. That's going to be very exciting. We're going to map the surface again in a lot more detail.
So if we did spend lockdown on Mercury, we could hitch a ride back in about 5 years.
Now, getting to Mercury is really hard. So, yes, you could, but interestingly, it takes lots of energy to slow down enough, if you leave the Earth, to get into orbit around Mercury. And that's why.
Or else you just fall into the sun.
Yeah. Otherwise, it's game over, right? So that's why Bepi Colombo has got to fly past the Earth and fly past Venus in order to change its orbit enough to then gain enough energy, to lose enough energy to get into orbit around Mercury. So it's a very complicated place to get to. But when you've got there, it's totally crazy because there's no atmosphere, so you will need a spacesuit. The bit that's facing the sun can get up to 450 odd degrees centigrade. But because it takes so long to turn on its axis in a day, the night side temperature can drop way down to, minus 180 degrees centigrade or so, or even colder. And because it doesn't have much tilt, the Earth tipped on its axis by 20-something degrees, 23 degrees or so, right? Which gives us our season. So that's why it's summertime here in the UK at the moment, and it's winter or it's spring here in the UK, and it's autumn in the southern hemisphere. On Mercury, it's like this. It's kind of orbiting but upright, which means at the poles, there are big craters, and the sun doesn't really shine into those craters. So actually, the temperatures there are some of the coldest in the solar system. So it's this really crazy fire and ice planet. You've got baking hot temperatures combined with freezing conditions where it's actually cold enough to have big blocks of water ice potentially in some of these craters.
So this is the George R.R. Martin planet of our solar system.
Fire and ice.
Yeah.
Son of ice and fire.
Yeah. And when they say winter is coming, it's kind of tricky for Mercury because it doesn't really have seasons. But certainly, if you were chasing the edge of the planet, the Terminator, you might find there was a place where you could, as long as you kept moving, the temperature might be so crazy and extreme.
Yeah, you could put a train and just track and be in constant dawn or dusk or something like that, and have quite balmy temperatures.
Yeah, you could.
Right.
Might be all right, but I mean, yeah, it's a very crazy, interesting place, and we definitely need to go back and get more information about it because we don't understand how the structure. So we know the surface. What makes up the surface, the geology of the surface is very different to the moon, but we need to understand that in a lot more detail. And we'd also like to really know what's really is going on with the temperatures at the poles, so we can really understand if there's any water ice there, because that would be very useful if you had to live on Mercury for any time. Hopefully you won't, because otherwise it's pretty tricky.
Well, the other thing about Mercury is there's so much solar energy, right? The sun is like right there. You'd be able to produce so much energy so quickly. But radiation, man.
You know.
Presumably, the thing that we are all trying to avoid by going into lockdown would also be damaged by radiation. So, potentially a healthy way to get rid of that particular problem.
Well, okay, so ultraviolet radiation is a great way of sterilising things. So, yes, it would certainly destroy pretty much anything organic on the surface. It's a real...
Including us.
It kills.
I mean, he just obliterated his argument there, didn't he?
We're taking ourselves out of the equation. But,
Yeah.
Sterile. That sounds good to me right now.
That would be pretty sterile.
Okay, so that's Mars and Mercury. Any other arguments to make?
I was going to say, the thing that I was going to say if I got Mercury is that obviously if we're living on Mercury, we're probably quite technologically advanced. And maybe if we were living on Mercury, we could mine the core, which would produce so much like metal minerals, which would be really good.
I think asteroids would be easier to mine, though.
Yeah, but we're not talking about asteroids, are we?
Not until the Q&A.
Yeah. Okay.
Excellent. I have one more point that I want to make about Mars, because we seem hopped over to Mercury's side. I quite like the idea of hanging out with the Curiosity rover. If we're going to have to self-isolate, we can't be near any other human beings, but you've got company.
Yeah. Yeah.
And its birthday is coming up in August, so you could be there, have a little party.
Yeah, because I don't know. I think as robots go, nuclear-powered mini dune buggies, I suppose, have an appeal. But
hitch a ride.
Yeah.
Moving very, very slowly.
Slowly.
Yeah.
All right.
Oh God.
Final round.
I know what our last two options could be.
What are you hoping for?
I don't think either of them are good, to be honest.
Yeah, I don't want either of these two, so let's see what she's got. Okay. It's Earth's.
Oh my gosh. I mean, it's just karma, isn't it? Like, it would have to be that way.
For the viewer at home, I don't think you saw this, but before we started recording, we were having a long conversation about how much Helena hates the moon.
Well, no. If this is going live, I put a disclaimer out there. I do not hate the moon.
In case
I like the moon. Like, I'm going to disappoint so many people. Like, I can't. I don't dislike the moon. It's fine.
It's fine. It's just
fine.
We see it every day. It's, it's a familiar friend. Okay, and that means, Neil, the last name from the hat.
Oh.
No, you know what it's going to be.
The elephant in the room.
Indeed.
Jupiter.
I actually think these are quite good against each other, to be honest. So, all right, let's make a...
Jupiter.
Well, Neil.
Yeah, well. Hold on, let me just get a moon.
You wouldn't think that the moon and Jupiter were.
I just want to say, like, I have a tattoo of the moon. I don't hate it. Like.
Okay.
So,
there we go.
Just saying.
I've got a picture of the moon on my wall. Can I show you?
Yeah, go on.
I don't know if this will be able to go in the video, but past my green screen.
Yay, moon!
Yeah.
It's so that picture, it was made by a Raspberry Pi. There is so I live in Leamington, and there's an artist here who constructed technologist who constructed a machine that draws pictures with you feed it a picture, and it's like on a wall, and you put it in front of a piece of paper, and it draws. And yeah, I've got the moon. So another personal bias there. My pictures I'm looking at a poster of Enceladus and a picture of the moon. So you got Saturn and the moon, didn't you?
Yeah.
Helena. Right. So I'm on Team Helena, clearly. But it's not up to me. So, I'm just here to moderate. It's up to the audience. So we've got a lovely, gorgeous picture of Jupiter behind Neil there. That's beautiful. What a gorgeous planet. Are you ready to go first, Neil?
I am.
Neil?
I am.
Excellent.
So,
fire away.
So Jupiter, basically, I've got the big one. This is the biggest planet in the solar system and it's basically one of the most complicated and interesting things that you could visit. It's another great big ball of gas, which you can see by having a look at it. You can see it's got a very complicated and interesting atmosphere, huge storm systems. Hang on, I'm just trying to point at it.
Is that a hat?
Yeah. So a huge storm system with a big red spot, which is this big sort of oval-shaped red blob you can see there. A huge hurricane-like structure in the atmosphere of Jupiter. Lots of very, very fast winds whipping around. Because it's out in the outer solar system, again, the temperatures are low. They're down at like minus 180 degrees centigrade or a little bit higher, maybe, depending on where you are in the atmosphere. So depending on where you are, again, you can find a place in the atmosphere where the temperature is okay for people, but you couldn't breathe the air because it's virtually all hydrogen, helium, with bits of, other traces and compounds mixed into it. So bits of ammonia, bits of water vapor. Basically, if it's any other kind of element, it gets combined with the hydrogen and turned into something like methane or ammonia or water vapor. Now, Jupiter has an amazing, crazy internal structure. Basically, as you go deeper and deeper and deeper into the planet, the temperatures get higher and higher and higher, and everything gets compressed and crushed. And so you think that inside Jupiter, and this would also be true for Saturn as well, but certainly for Jupiter, the pressures and temperatures are so high that the hydrogen itself can turn into this weird metallic-y type phase. So it's like a kind of metal hydrogen inside it. And then we think that churning away is generating an enormous magnetic field. And in fact, the magnetic field of Jupiter is one of the biggest structures in the solar system. If you could see it in the sky, you'd see it sort of extending out way beyond the planet, almost out to Saturn.
Beautiful northern lights.
Yeah, incredible aurora. This gives you incredible aurora. Amazing, glowing structures on the the upper atmosphere of Jupiter. Is all the stuff that's coming out of the sun gets collected and channeled in, and then excites and produces a beautiful aurora. So it'd be an amazing place to visit. It is an amazing place to visit. We have a fantastic spacecraft at the moment in orbit planet called Juno, which is a NASA mission. And if you see some of the cloud structures and things, if you go and look it up later, you'll see it's got the most fantastic, dynamical, weird patterns in the atmosphere from all these crazy fluid flows. But the other thing about Jupiter is, of course, it has a system of really interesting moons. So I'll just bring up a picture of the sort of classic 4 big moons. So these are very important in the history of our understanding of how the solar system came to be. So I
just want to say, but when Neil was bringing it up, when I was a kid, it was seeing the moons of Jupiter through a pair of binoculars that got me interested in planetary science.
That's amazing.
Or one of the reasons.
That actually is because I tweeted about being able to see Jupiter in the night sky while I was on a ride somewhere, and Neil said, "Have you ever seen it through a telescope?" And I hadn't. So I went to visit Neil at Oxford and I got to see it through a telescope, and it was absolutely wonderful.
Isn't it the most incredible thing? It's so extraordinary because you can see the banding on it. It's amazing. Yeah. The moons, they were little pinpricks of light, but you could still see them, and they changed night to night, and it was just the most incredible thing.
I've got to say, to avoid bias, on the same night that I saw Jupiter, I did also get to see the moon very close up, and that was also very exciting. So for the current round, things I've seen through a telescope.
Right. Okay. So with Jupiter, it also has this system of really big moons. They're all about the same size. There are 4 really big moons, and they're called the Galilean satellites because they were first observed by Galileo when he took a telescope and looked at Jupiter and saw what looked like a mini solar system.
And these are the ones that are named after a mythical figure's wives, am I right?
Something like that.
Yeah, because Jupiter is the Roman name for Zeus, and like he was always like, Zeus was a bit of a, of a player. He got about, and so they're all supposed to be like monitoring him or something like that. Wasn't it something like that?
Zeus's wives. Excellent.
So a trip to Jupiter for your self-isolation requirements, if you can survive the harsh radiation environment and all the other things that are naturally nasty about it, you get a fantastic range of different places you can go. You can see essentially tremendous different processes that we see across the solar system, all in one planetary system, one planetary moon system. So first of all, you go to a moon like Io. So Io, which is that one in the top corner. That one is the sort of one. It's also known as the pizza moon because it looks like it's covered in kind of melted cheese, but that's not molten cheese. That's actually frozen out sulfur that's been erupted from volcanoes all the time on Io's surface. Io is one of the most volcanically active places in the solar system, and the reason is it's being squeezed and stretched and pulled during its orbit by the other three big moons and Jupiter's gravity. So essentially the planet is being sort of gently turned inside out. It's producing these huge volcanic eruptions. Then, if we move out from Io, we then end up on a moon called Europa. Now, Europa, which is the one next to the pizza planet, that is also an incredibly weird place. It's one of the places in the solar system where we think there might be a large subsurface liquid ocean. It's got very young surface, covered in ridges and ice. If you look at it, it looks like kind of lots of icebergs all interlocking and crashing into each other. We think that's probably because, again, because of the way the gravity is pushing and pulling the moon, deep inside it, there might be some sort of liquid water. And of course, that makes it terribly exciting for thinking about possible habitats for things in the solar system. So basically, you've got Europa, very young surface, Io, massively erupting volcanoes. Move out a little bit more, and you get to Ganymede. Now, Ganymede is really interesting because it's kind of halfway between being dead, a bit like the Earth's moon, and
wow, shade.
Yeah, right, and something really active like Io or Europa. So you could probably go to Ganymede and you could study essentially the processes that are going on in both places, but also sort of hang out, take a quick trip into some new terrain, jump back, see something ancient. Be kind of fun. Good place to go. So Europa would be kind of fun for skiing. Io would be, like for the real danger freaks who just don't want to stick around for too long because the radiation will get you. But also you've got an erupting volcano probably nearby.
Or for people who come from places where there are a lot of volcanoes and they want to, like someone who is from Hawaii on Earth and they want to go somewhere that feels familiar to them.
No.
A bit like Hawaii on speed, I think.
Someone who comes from Hurricane County, in the States, maybe they want to go somewhere that feels a bit like home.
They have the same level of danger.
Yeah.
Yeah, okay, yeah, because they wouldn't want to back down on that level of living in a complex. Anyway, that's a very British perspective, by the way, to have that kind of extreme weather or earthquakes or volcanoes here. They happened a long time ago. I would say for mine. So then finally, if you really want to go out to Crusty Moon, as I might call it, then you would head out to Callisto. Callisto is pretty dead. It looks smashed up. It's got a huge number of craters. If I move my head out of the way, you can see a picture of it there in the top corner. And essentially, it's got a huge number of different craters, lots of impact structures, probably one of the most ancient surfaces in the solar system. So, yeah, Jupiter, it's got everything. It's kind of like a theme park playground for planetary science.
Perfect.
Take that moon.
What a good argument. Helena, are you ready?
I'll have a go. The Earth's moon, it's the thing that we all see in the sky at night. It is our companion, the moon. It's great. Obviously, it's great, and I love it. So the moon is Earth's only companion. It's our only moon, and it's actually the only place in the solar system where people have set foot on other than Earth. And I would just want to change the background to a picture of the people actually on the moon. Hold on.
But importantly, for self-isolation, we should point out they're not there anymore.
Oh, no. They haven't been there since, I think, 1972. I was going to say 1972, but actually that means that there were only people on the moon between 1969 and 1972. It's 3 years. When I was a kid, I used to, I wasn't one of those kids that sang in the shower. I used to recite the astronauts' names who were on the Apollo missions because, I'm surprising Neil here. He's like, she's a whole different person. I did not know who she was.
I love that. That is adorable.
Yeah. So the moon there's a lot of study that's been going into the moon about sort of potential habitation on the moon. It's probably in reality, it's probably one of the most likely places that humans will go to next, or the humans will return to in the kind of upcoming decades, upcoming century, things like that. The moon, the moon, it does have some water ice in the poles, which is really, really important. It is small. It doesn't have very much gravity, which is a problem, but it does mean that you could like bounce around, and that could be fun. And it's also not got an atmosphere, which isn't great either. So you would have to wear a spacesuit. But the moon is really interesting because it's basically tidally locked with the Earth, which means that we only ever really see. Well, I mean, you'll see if you look at the moon at night, you only ever see one face. And for a long time, that was the only face that we could study. And then with the kind of like rise of the space age and things like that, we managed to get views of the far side of the moon, and we found that it was this incredibly cratered old surface, which was actually quite different from the near side of the moon. And that's something that I think is a really, really interesting thing that we don't really understand why that is. Is it that the outer side was more heavily cratered? Why is that the case? That's something that I think would be really, really interesting.
A Chinese mission landed on the far side of the moon last year, right?
They did, yeah. Chang'e 4 or Chang'e 5, I think. And actually, they were really interesting because they managed to grow something, some sort of very hardy plant in a isolated environment within their spacecraft on the moon, which I think is a really good sign if we were going to live there, because you might be able to use it's evidence that you might be able to grow things on the moon. You would have to live in a habitat on the moon. The other issue with living on the moon is radiation. We have no atmosphere to protect us, so we would have to create a kind of shielded shelter. We could actually use lunar soil as like a shield to protect us, which would be really good. The moon is very close to the Earth, so that means that communications would be very, very quick. I think it's like in the order of 1 or 2 seconds. You'd be able to communicate back home very quickly. It's also very quick to get to. The other really cool thing that I think is really interesting about the moon is because the surface is so old. So it's not got tectonics or anything like that, like the Earth. Like none of these, quite a lot of these planets that we've been investigating, like the surface is very old and heavily cratered. It means that it's actually kind of pristine and very primitive. It means that we could actually use it to investigate some of the things that were going on Earth right when the moon was forming. So potentially there are Earth meteorites on the surface of the moon, and that would be really, really cool for us because they could be even older than any of the rocks we have on Earth from Earth, and we could begin to investigate that. What else about the moon? So there's been quite a lot of research going into potentially harvesting materials from the lunar soil, and it looks as though you were able to create water from hydrogen and oxygen in the lunar rocks. Yeah, I think it's okay. It's close, which is nice.
Yeah, 3 days away, which is helpful.
Yes, it takes 6 days. Took 6 days for the astronauts to get there, which is quick. But the moon is cool. The one downside to the moon, like I was saying with Mars, is that it does look as though it might just be a chunk of Earth. So the moon, one of the main theories for how look at Neil's face. One of the main theories for how the moon formed was actually that in early Earth's history, a kind of small body about the size of Mars crashed into Earth and kind of threw out a huge amount of material that then kind of settled out into basically like a ring system around the Earth, and then that kind of coalesced and accreted together to make the moon. So actually, like I was saying, it could be kind of, you could use it to kind of probe back into Earth's history as well as the moon's history, which I think is really interesting. So.
I was going to ask, if the Earth has, bits of the moon in it as part of the planet, then it's like, I guess being on the moon is kind of like having a bit of home with you.
Yeah, exactly.
Okay.
I think look at the Earth and wave.
Yes.
Yeah, you can see it. You get these absolutely extraordinary, Earth rises. We've all seen that shot of the Earthrise. I think it would be incredible to be able to see everybody you've ever known in one.
Although also potentially a downside in that, isolation is lonely, and maybe it would be easier if you couldn't constantly see a reminder of everyone you love being very close to you, but not.
Maybe.
Yeah, but the internet would still work.
Huh?
The internet would still work.
Would it?
Well, a good communication satellite. got a second delay, it would work.
Oh,
Yeah, 1.5 seconds is fine.
I'm sold.
I think gaming would be tricky. The lag would be a bit much.
You just have to do it not online. You'd be all right.
Well, yeah, I know, yeah, well, you could do it on the moon, but I mean, can you imagine? How many milliseconds? A lot. Yeah.
Yeah, exactly. Terrible. You just wouldn't. Yeah. I don't know. It's the moon is cold though. That's the other problem. It's got an atmosphere. It does get chilly, and it's night because it's tidally locked. It rotates at the same time as it kind of rotates with the Earth, which means that its day-night cycle is ridiculous. Which means the nights get very cold and very dark and thoroughly unpleasant.
Yeah, and your head would be freezing in this picture, right?
Yeah. So like here, I'd be like minus something horrific, and here I'd be positive something horrific, and you just have to sit in the middle.
Neil, follow-up question about Jupiter. You mentioned the red spot. Am I right in thinking that has changed in size?
Yes, it grows and shrinks and changes colour over time. But it's certainly been present for the last 200-300 years, where we've had telescopes good enough to resolve it, to see it. So yeah, it could be
not going anywhere anytime soon.
Well, we don't know, but things can always surprise us. It certainly seems fairly stable at the moment. It does change shape and does change colour over time.
Isn't it? They say it's about the size of 50 Earths or something like that.
Yeah, it's crazy. It's massive. It's multi-Earth. Everything on Jupiter is just big. And the other thing that's nuts about Jupiter, is crazy about Jupiter, is the fact that it takes 10 hours for a day. So the moon turns very slowly. It's a 28 days to go all the way around on its axis, because at the same time it takes turning around the Earth. But on Jupiter, a day is 10 hours. How massive the planet is. It actually means it gets spinning topped. It's all the stuff starts to bulge at the middle. So if you see Jupiter, it actually looks slightly flatter at the poles than it does in the middle.
Oh, like Bennu and Rugu.
Yeah, it's crazy.
It's got a spare tyre.
Yeah, it's like it's got a spare tyre. Yeah.
Excellent.
Bonkers.
Okay, do you two have any follow-up challenges or questions for each other?
I want to challenge Neil about radiation from Jupiter.
That's a big one for Jupiter.
It is. So Jupiter's got, he mentioned the magnetosphere is one of the largest structures that, in the solar system, but it also is a source of absolutely insane radiation. And one of the things when you're planning a mission to Jupiter is you have to take into account that you're going to be flying through these incredible radiation levels. So, and I know that Io and Europa are, Io's pretty, you get fried. Europa, you might be able to kind of shield yourself if you manage to dig down into the subsurface ocean or something like that, and the ice could protect you on the surface. But yeah, radiation, man. I think Callisto is good. Yeah, Callisto I think is a pretty safe bet because it's calm, it's dead, no radiation, not a bad place to live, to be honest.
A quiet life with fantastic views. Callisto is probably your best.
Yeah.
Yeah.
Well, Callisto's been investigated, hasn't it?
Yeah,
as a potential habitable zone for humans by NASA.
I think, yeah, you're right. Radiation is the big problem. I mean, that, and if you actually went to Jupiter, you'd be simultaneously asphyxiated and crushed by the pressures in the breathable atmosphere. But putting that to one side, we
found a way to deal with that.
Yeah, but you would probably have been fried by some radiation on the way in anyway. So, I mean, the Juno spacecraft actually has very elliptical orbits, so it spends as little time as possible in the very high radiation regions around Jupiter. And in putting a spacecraft, we're hoping to send a spacecraft to Europa in the next decade, and that will have very carefully designed, very carefully screened electronics to cope with being in this big radiation environment. And even then, we don't expect it to last particularly long, no more than a few hundred days or so. So anyway, yeah, I mean, you might want to stick around on some of the outer moons a bit more. Just sort of just watch the world go by from there.
I mean, a lot of these places we've discussed are you're gonna fall into the trap of it. In the travel to them, you might be subjected to some sort of higher radiation levels and things like that. And the moon is close, doesn't take very long, which reduces the amount of radiation you would be exposed to on your journey. So
yes, that's true. But
it is, isn't it? See, moon's great.
Well, what's at the end of the ride? It's the moon.
Yeah, there's an American flag.
Yeah,
there's some other
footprints.
Yeah, footprints. There are some other people have left other things, haven't they? Isn't there a photograph?
Yeah.
left on the surface of the moon. So
There's
you've got things to look at.
golf ball. I mean, there's lots of strange things on the moon.
Yeah, Al Shepard, first man to play golf on the moon.
There you
Yeah.
go. The moon, you can play golf there. So
You can, and you know what? You have to hit it a little bit, and you go really far. Great.
So we'll send all the golfers to the moon. You know what I love about this conversation that we've had is that we have found some great advantages to all planets and Earth's moon that I have come up with and put in my hat. So I think this is actually going to be really difficult for people to decide. If you are watching this, you will be able to vote. We're going to have polls. I think we're going to have one per round and then an overall. So we'll be able to see who won, for instance, in the battle between Jupiter and the moon. And we will also be able to see what is the overall winner. So the number one place that people would want to spend lockdown. So things that people might want to consider, you know, you've got weather, you've got temperature, you've got what kind of sights you'll see, what kind of activities you could do. We've had cooking pizza, we've had golf, we've had, you know, water sports. So it depends what kind of person you are, what you want to do in your lockdown. You want to think about like safety, you know, meteors, right, and things that might crash into the planet that you're hanging out in lockdown. You want to think about that kind of thing. Size, you know, maybe you want to go to Jupiter because you know you'll never see the same thing twice, or maybe you want to go to the moon because you want familiarity and you want to be able to retrace your steps and things like that. You've got, again, distance, so how long it takes to phone home, if you want to phone home, and how long it takes to get there. Things like, oh, what kind of companionship you might have. I think this is only Mars that can offer you a rover to talk to. That's a bonus for sure. The radiation is definitely a factor to consider, although, you know, maybe you want to think of it optimistically like I have. It'll be very sterile on Mercury because of how high the radiation is. And then, you know, other things that we haven't talked about. Is there some kind of power source so I can play my video games? You know, could we get electricity somehow? What would it sound like there? Is an interesting thing to think about. Could I practice my singing on these planets? What would my voice sound like to my own ears? And has anyone been there before? So, you know, we've landed things on Mars, we've landed things on the moon. Maybe you want to be someone who is a groundbreaker and is the first person to go to a planet. So that's something to think about. So keep all of those things in mind and all of those arguments that Helena and Neil have made. And make sure you vote in our polls on YouTube and on Twitter. Again, on Twitter, we are at Oxford Sparks, so make sure to follow us. And yes, exciting news, we've got a Q&A coming as well. So if you have watched this video and you have follow-up questions for Helena and Neil, we will all be doing a live Q&A, although I probably won't be very good at answering your questions, so please direct them to Helena and Neil instead. Do you have anything in particular that people should ask you about?
Well, I can talk. My particular expertise is not necessarily planets, but if you want to talk asteroids and Ceres and things like that, I'd love to talk about that. Also aliens. You know, I love chatting about aliens.
How about you? Just Mars?
Yeah, I think there are the things that people should also be aware of. There are other things in the solar system, such as comets and asteroids, which are also very interesting and tell us a lot about how we came to be. And also, I think people shouldn't forget, although it's pretty tricky at the moment because times are tough, just look outside the window and think about the planet you're on now. Because I think that's actually quite an important point. We've been everywhere in the solar system. We've visited most places. We've been to several asteroids. We've flown past comets. But there's still one thing to say about the Earth, is that we evolved here, so we're pretty well set up to live here, even when times are tough and difficult.
Yeah, I think the one thing we can agree on is probably that if we had to pick anywhere in the solar system to live, it would probably still be Earth.
So yeah, we should look after it.
Yeah. All
right, an excellent note to end on. If you want to tune in for the live Q&A, that is on Thursday, May 7th, which is either today as we're recording this, tomorrow as we're recording this, or today as you're watching this, at 5:30 p.m. UK time. Maybe we'll get some people calling in from elsewhere to ask us their questions. That would be exciting. But for now, thank you so much for watching the debate. I hope you enjoyed it. Do let us know what your favourite parts were, what your favourite planets are in the comments. And follow Oxford Sparks on Facebook, Twitter, and even Instagram as well. Thank you so much. Bye from me, Helena, Neil.
Bye!
Bye from the moon and from Jupiter.
Exactly.